The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
So our next presentation is on repair application procedure number 12. That is concrete repair by Shotcrete application. This was being presented by Charles Hanskat. Charles is the technical director for the American Shotcrete Association, so he's certainly an expert in this field. He's also very, very active with ACI. He's a fellow of ACI. He's also a fellow of ASCE, and he is currently a board member of ACI and vice chair of ACI's Strategic Development Council and chairs the outreach committee of the SDC. So join me in welcoming Charles Hanskat, please.
I'm Charles Hanskat, Executive Director of American Shotcrete Association, but I already had the intro, so I'm going to go fast. I'm going to tell you about Shotcrete. I'm going to give you an hour and about 15 minutes. So it's going to be like that FedEx commercial you ever saw where the guy speaks really fast to convey it. I'm just showing this. This is a video of Shotcrete going in place. How many people have seen Shotcrete? Not everybody. But what we're taking very low slump concrete, shooting it in place, basically making it no slump concrete to build vertical or overhead surfaces in place. This is wet mix. You can see the concrete going in place, fully encasing the rebar. We're able to visually see all the concrete going in place, so we know when we get good encasement of the rebars that we're getting full consolidation of the concrete. So we'll just move ahead. Just wanted to show you what it looks like. Shotcrete is a method of placing concrete. I get calls all the time. Well, what's the fire resistance of Shotcrete? It's the same as concrete because it is concrete. It's pneumatically taking concrete, placing it at high velocity. When we say high velocity, we're talking 60 to 80 miles per hour. So if you think about it, if you're driving down the freeway and you hit a column, concrete column at 60, 80 miles an hour, that's a ton of impact, isn't it? That's what we do with every square foot of concrete that's placed by the Shotcrete method. That's how we get consolidation. That's how we get it driven in place so that it can hang not only vertically, but on overhead surfaces. And some people think we're a relatively new innovation. We're not. We actually predated in 1907 when we were started the ready-mix delivery trucks. Ready-mix didn't happen until 1914. Shotcrete was one of the original ways to produce high-quality concrete in place. We have two different processes, dry mix, wet mix. The original process was dry mix. That's where we basically take dry materials. So we're taking this encased bag materials with a pre-dampener, putting it into a gun, using air to convey it pneumatically through the hose, and then we use a high-pressure water source to hydrate that dry material right at the nozzle. So this is where we make the concrete. And in the nozzle, you can see here what we're doing. We're atomizing that water. We're forcing the dry material through, and that is where we actually make the concrete. We're adding water to start the hydration process. We get mixing in the nozzle. We get mixing as it flows through the air, and then certainly even completing the mixing when it impacts on the surface. Here you can see a typical Shotcrete, dry mix Shotcrete rig. This is our little concrete plant. Here we have a super sack, dry materials. We have some very sophisticated materials now. Water for the pre-dampener. This is the gun, and then the hose. We can go to remote sites. We can go in sites that don't have a whole lot of space to work in the underside of a bridge deck. Maybe something where you have traffic that can only be delayed a certain time, to get one lane accessible for the work. So we can work in very tight locations. The other process is wet mix. Wet mix is developed in the 50s and 60s when we started to get concrete pumps that were more reliable. These are basically, most of our pumps are hydraulic cylinder pumps, the dual cylinder pumps that pump the concrete from 1,000 psi to up to almost 2,000 psi through a hose, the pre-mixed concrete. Then we add air at the nozzle to accelerate it to that 60 to 80 miles per hour. So the fundamental difference, dry mix, we're adding water at the nozzle. Wet mix, we add air at the nozzle. Because in dry mix, we are conveying all the materials through the hose, we tend to use a bigger air compressor. So if you're on a project using dry mix, it will generally have a larger air compressor than what you would see in a wet mix application. And if you're seeing good shotcrete going in place, it shouldn't be a 125 CFM compressor. Probably about a 185 would be the least that should be used for shotcrete, because we want that high volume, high velocity projection from the nozzle. If it's dry mix, we actually go up to probably about 500 CFM compressors. Here you can see the wet mix nozzle. Basically, material comes through. It's pretty typical. Our hoses are 1.5 to 2 inches. Comes through, and then we use air to accelerate. One of the cool things about wet mix is, though we can actually add a rapid set accelerator, we can get almost instant set of the material in place, and we can get very early strengths. If you added a rapid set accelerator in your ready mix truck, you wouldn't get it out of the ready mix truck. Because we can add it right at the point, right immediately before placement, this allows us a lot of flexibility when we're using accelerators. And here you can see we use a small line pump. Generally, it's a 3 to 5, maybe even 6-inch discharge out of the pump, and we reduce it down to the 2-inch, 1.5-inch hose that's used for the actual hand nozzling. I get a lot of questions. Well, which one's better, dry mix or wet mix? And really, both done properly with the proper material mixtures, placement, and equipment will perform equally. Dry mix is not more porous than wet mix. Wet mix tends to have a little bit higher water cement ratio because we have to pump it through that pump and through a fairly small hose, right? So actually, dry mix tends to be a little bit stronger, a little bit lower water cement ratio. And this is a typical application. How many are from up in the north where we get snow? What happens when you get snow? You want to melt the snow, you use salt, right? Parking garages. Here you have a joint that goes through. It's basically corroded the reinforcing. If I was going to form and pour this, what would I have to do? I'd have to certainly get my substrate correct. I'd have to expose the steel. But then I'd have to put up a form, right? I'd have to support the form. And then I have to figure out, well, how am I going to get concrete in there to get the air out so I get full bond of that new concrete to the existing concrete? With shotcrete, all we have to do is get back to a sound substrate, and then we can shoot it in place. And we can see every square foot of that concrete going in place to know that we have proper consolidation and encasement of the reinforcing bars. The other cool thing is we can max the texture. When it's up there, we can do any kind of finish on that. And if they want it to look like this, we can finish it like it was cast on boards, if it was cast on plywood. Or if they want a special finish, we can come in and do circular columns like this. Very easy to match the existing textures. Here you can see large bridge retrofits where we're coming in. It's been used extensively for seismic retrofits. I know the WRAP document is about repair, but it could also be for seismic strengthening. Getting back once again to sound substrate and then putting your reinforcing up in this case and then shotcreting in place. Another big application we see is in culverts, sewers, water lines that have been corroded, coming in, actually getting back once again to sound substrate and adding shotcrete concrete in place. There's a lot of corrugated metal, galvanized metal culverts in place around the country. Galvanizing is a temporary thing. It doesn't last forever, and we're seeing many that are 40, 50 years old, that galvanizing's gone away, and they have to either replace the culvert, or what many people are doing, you're coming in and shooting a concrete pipe in place with shotcrete. Marine structures have been using a lot of shotcrete. Once again, you have a very aggressive environment, salt exposure, wetting and drying. This is actually a lighthouse that was up in the northeast part of Canada, and they had large tides up there, I think 15-foot tides. I know I went up there and the sailboats were floating in the water, and then I looked out later and they were down in the mud just on their sides because of the high tides. Here, because this is a concrete base, a lot of deterioration between the water line, the high water line and the low. So what they did, they came in, shot off rubber rafts at low tide with an accelerator, got it in place, and strengthened that without having to worry about form work. Or basically, we brought our concrete batch plants out there by using pre-mixed bag materials. And Shotcrete's one of the most sophisticated users of concrete. We use certainly superplasticizers, high-range water-reducing admixtures, so we can maintain low water-cement ratios and still get it pumpable, workable through the small hoses that we use. We use alkali-free accelerators. Microsilica is really popular. Microsilica is great for reducing permeability and chloride ion penetration in your repair materials. We use steel synthetic fibers. And a lot of our contractors are using hydration control. This is where you can actually put the concrete to sleep for up to 3 days. We don't need that much, but it gives us much longer than the 90-minute window that's typical for concrete from when it gets water added at the site to put in place. We can also add things like corrosion inhibitors. We can use a variety of supplemental cementitious materials. Silica fume is obviously one of our popular ones. Anybody here use silica fume in concrete? You found it was very thirsty, right? Sucked up a lot of water. You really have to get water on it quick. But it also makes it sticky, so it'll stick better when we're shooting overhead. And it also allows us to shoot thicker layers. So if you have a repair that's 3 or 4 or 5 inches thick, we can do it in one layer if we're using silica fume because it holds together. We also use fly ash. Fly ash increases our pumpability. A lot of times if you have a mix that's not working really well with just Portland cement, you can add fly ash and it'll help to kind of slick the line a little bit more. And we've used mixtures even I've heard up to 70% of slag. So we are very sustainable in using recycled materials. And most of these are good for shotcrete, good for concrete, reducing permeability. Class F fly ash helps mitigate problems with ASR. And a lot of people say, well, you know, shotcrete, when it, what's up with the air content, with air and training? We use air and training in wet mix. You get it in the pre-mixed concrete truck. In dry mix, we actually have admixtures that are in the pre-bagged materials that will allow us to form these little air bubbles that are the bubbles that are essential to having freeze-thaw durability. One thing that we do get, though, remember the impact? We're talking 60, 80 miles an hour. We knock air out. And so we do tend, if you measured 7% at the truck as it came out of the truck, it may be 4% in place because what we do, we knock out the bigger entrapped air bubbles. We keep the little bubbles. Those have a lot of surface tension, but the big ones get knocked out. So we keep very good freeze-thaw durability, even though you do lose a little bit of air content. Rapid set accelerators, really heavily used underground. That's not a repair application, obviously, but where they need to get in and stabilize a excavation so that they can get on to the next. But it's also used quite a bit. I mentioned that lighthouse that had the instance where they needed to get it in place, set and strength early. May happen on a bridge deck, underside of a bridge deck. You can only have part of that open at night, or maybe you got to put traffic on it on the bridge very quickly afterward. You can use a rapid set accelerator, get it to set very quickly, and also you will get strength. You can get 1,000 psi, 2,000 psi in a matter of hours. Another thing we can do with shotcrete, we can use alternative cements. I'm not showing it up here, but we can use the very, very rapid set cements that can get us high early strength. Predominantly that's used in a dry mix application because what are we doing different in dry mix? We're not wetting it until it's right at the nozzle. So it allows us to use a lot of these alternative cements to get that concrete in place. One thing, if you do have a job that's using accelerator, be very careful. Too much accelerator is a bad thing. Too much accelerator will make your concrete less strength long term. You know, and there's some superintendents that say more is better, and maybe it might set a little bit faster, but it really does significantly affect the strength. So you need to be sure that it's very closely dosed in the volume of concrete going in place. Fibers, we use microsynthetic. Those are used a lot for control of early age plastic shrinkage cracks, which is a problem in a lot of our repairs, right? Where surface is exposed to air, wind, might be a dry climate like here in Las Vegas. And so the microsynthetic fibers help to kind of control the early age plastic shrinkage cracks. When we get into more structural applications, we do use steel fibers, and then the macrosynthetic, which is a longer, bigger diameter fiber. Those are actually about as effective as steel fibers in providing resistance against more of the long-term cracking. Mentioned here natural. We've also been using hemp fibers that actually they actually hold some water, provide some internal curing, which is really good for a repair job, because you actually, it's almost like internal curing of your repair as well as external, so you're going to get less shrinkage cracks overall. So what do we do for surface prep? You can shoot, if you're going to shoot on bad concrete with good shotcrete, where's it going to fail? It's going to be in the bad concrete. One of the biggest problems in a lot of jobs is, the engineers come in and evaluate and say, yeah, we think we'll have to take out 2 inches, and you chip in and it's 3 inches and 4 inches and 8 inches. And at some point you have to have a structural engineer evaluate when you've taken too much. But you got to get back to good sound concrete, chipping, scarifying, hydrodemolition. I think that's the next talk. Has been real popular in shotcrete applications. If more than 50% of the bar is exposed, if you have just half the bar showing, it's okay to go ahead and encase that with shotcrete. If there's more than 50%, we like you to excavate back behind the bar so that we can get shotcrete back and actually tie that in. We also want to bring the surface to saturated surface dry. That means that it's wetted. We fill the pores of the concrete surface with water, and allows us, when we shoot against it, we drive that paste into the surface. It's not really diluted. It allows more of the hydration right at the surface. If we have running water, it's going to be too diluted. We're going to lose some of the bond. If you shoot against bone dry concrete, what's it going to do? It's going to suck the water right out of the paste, right at that interface, and that also can reduce bond. We don't like feathered edges. We like to have a saw cut, 3/4 an inch, get back behind the steel. Why would we not like a feather edge? How about anybody here do a feather edge in your repair? That's the first place to fail. It goes through a summer-winter cycle, and a little bit falls off, and then a little bit more and a little bit more. If you have a nice shoulder like this and shotcrete against it, it gives it enough meat that it can hang in there and act as a structural repair. Many of these are saw cut, but we don't want to shoot against the saw cut. So we like to have that surface sandblasted or roughened at least so that we can get good bond of our shotcrete during placement. We never recommend bonding agents. I got a lot of inspectors or a contractor calls and says, the inspector told me I had to use a bonding agent. Well, a bonding agent's fine when you're casting concrete, but remember, we have a very active process. We're impacting at 60 to 80 miles per hour. If we had a bonding agent, number one, we would probably strip it off because we're in fact sandblasting it in place. And number two, if the bonding agent is outside its open window, it can actually act as a bond breaker. And because we're driving that fresh and relatively high cement paste content in our shotcrete into that surface, we get excellent bond. You can typically see at least 145 psi bond strength, tensile bond strength. And if you look at the literature from the bond shear strength that allows a section to act monolithically, you need about 200 psi. But the tensile strength, you multiply by 2 or 3 to get your equivalent shear strength. So we are basically creating monolithic concrete when we shotcrete in place, or if we have individual layers of shotcrete to build out a thicker section. And why are we getting such good bond? High energy placement. I guess I got ahead a little bit in terms of the slide, but 138 was the lowest here, but you can see tensile bond strengths, 400 psi, 450. Here's a lower one, 162. Generally very easy to get roughly 150 psi. If it's less than that, there's some problem with the surface prep or with the placement or the material in some ways. And here's a existing substrate. Here's where we shot against it. And it's very difficult, except for color, to see that we have any kind of interface there. How do we control thickness? I mean, we're shooting it and it's coming out of that nozzle. We actually use what we call alignment wires, ground wires, shooting wires. Here, this is the horizontal, so they can make a radius here at the bottom. But the engineer, the inspector can come up and say, okay, well, I got 2 inches of cover here, so that's what I need, because you shoot to it, just a little bit past it, you finish it right to the wire, and you know you have that 2 inches of cover. It also helps us define some of the more unusual curves and radiuses. What kind of finishes can we do? Anywhere from a gun finish to the most expensive carved finish like this. A lot of people think this is Shotcrete. This is our old gun finish. If you go in a wine cave or underground, yeah, that's what you'll see. But our guys have gotten really creative. We can actually float. We can steel trowel finish. We've shot it as fresh concrete. We can do anything to that surface. We could stamp it to make it look like brick. We can carve it to look like rock. We don't like the steel trowel finish just because how do you get the gloss from the steel trowel finish? You pull water up to the surface, right? So higher water cement ratio means it's less strength, so it will not perform as well durability-wise. The other thing is that's a glossy surface. If it cracks, a little bit of cracks is going to show more. So we can do it. We don't like it. This is probably the most common finish, a float finish or a sponge finish. In repair applications, though, you know, if it's a highway pier, we can match whatever the texture was before. Now, one of the things we can't match is color, because 50 years ago, concrete wasn't the same materials that we're using now. And we're using fly ash, silica fume, slag. Those actually affect the color. So we can match the texture, but colors can't. So if an owner is looking for a consistent color, maybe use a cementitious coating that allows you to still have that concrete color, but provide it consistently. And we can do multiple layers. If you have a deep repair, we can shoot out close, and then we take care in this final layer. It all acts monolithically and provides that nice float finish or a steel trowel or a carved rock finish. So here you can see they're shooting a curved section, no formwork, easy to come in and shoot. We do, as we get off the ground, like to use man lifts. This is what I'm talking about in terms of color. This is the old concrete versus the new. And if it's a hot DOT bridge, maybe they don't care. It's underneath the bridge. If it's out there and some architect's worried about how that repair looks on their building, you can come in with a coating. Once again, it's just concrete. So anything that works on concrete as a coating can work on a shotcrete placement. And when you have shotcrete, there's a lot of things different than casting concrete, right? We have the nozzleman. We have the fact that the nozzleman's in dry mix controlling your water cement ratio. In wet mix, he's controlling the placement, making sure he gets full encasement. So we strongly encourage that you have ACI nozzleman certification for your nozzleman. This is both in the process, it would be either dry or wet mix, and the orientation. Vertical overhead. If you're doing overhead repair of a bridge deck, you should require if it's wet mix, a wet mix nozzleman certified in overhead placement. These are great references. I know the RAP document is really just a basic primer. So if you're going to get into shotcrete, look at the guide to shotcrete. This is the best resources we have. It's a primer. It's written by ACI Committee 506, which is probably one of the committees that has the most contractors. So we've written it where it's very readable. It's not like going to a 224 cracking document and trying to figure out what they're saying. We talk about crews. The other document is specification for shotcrete. And then we have visual shotcrete core evaluation. And then these are the resources, shotcrete.org, that's where I'm from. We're the American Shotcrete Association. And then concrete.org, that's the certification process that is administered by ASA, and also all our 506 documents. So that's all I have. I might have taken a few minutes more, but you had a few minutes more. So any questions?
When you're doing multiple lifts, are you ideally letting it set initially before you put your next lift on, or is it right away?
Well, let's define lifts. If I'm doing this isn't a repair. If I'm doing a 2-foot thick wall, a new wall, we're going to bench it from the bottom to the top. So we may do a bench that would be about the height for the nozzleman to be working 5 feet. We're going to let that set because when we add the next lift on top, it has to be able to carry the weight of that new fresh concrete. If I'm doing multiple layers of shotcrete through a section, they still have to be pretty well set up. I mean, you're going to want your final set. If it's going to be a longer time than just that same day, we actually say that it should be roughened. It could be a broom finish. Then the next day when you come in, it'll be wet. It'll be cleaned. You could use a pressure washer, clean it, and then get a saturated surface dry. Once again, we like that saturated surface dry to really work with the paste. I pointed out that, you know, you can see visually everything going in place. If you know Shotcrete, you can see that you're getting proper encasement and that it is being consolidated properly. We do have compression tests that we don't do cylinders. What we do for a QC, for compressive strength, we shoot into a panel quart. There are ASTMs for that. ASA has a program where we actually do a Shotcrete inspector education because there's a lot of inspectors that know concrete, but they don't know Shotcrete. So we go through, there's actually 40 different things that we can tell that inspector to look for to verify that they're getting quality in place. So we do have testing, but we also have the ability with the inspector, a knowledgeable inspector, to be able to quantify that it's going in place correctly. Thank you.